Hey Tesla fans! Automobile high voltage, welcome to the ultimate hub for everything Tesla. From groundbreaking updates on autopilot and full self-driving, to the latest on Cybertruck, Optimus, Gigafactories, and Elon Musk's bold innovations, we've got it all, right here. If you're passionate about the future of electric vehicles and want to stay ahead of the curve, hit that subscribe button and turn on the bell, because this channel is fully charged with Tesla news, deep dives, and tech breakdowns every week. Let's start our video. Since leading Tesla, Elon Musk has always taken a unique path, unlike his rivals. He wants Tesla's products to stand out and feel a bit unusual, something you won't find at Ford, Rivian, Toyota, or any other company. This isn't just about electric cars anymore, now it's happening with Tesla's humanoid robot, Optimus. The difference lies in how Tesla builds Optimus. While competitors pour money into making robots run, jump, or think super smart, Elon Musk says Tesla's going a different way. Over half of Tesla's engineering team is focused on just one thing, the hands. With the vision of the world's richest man, Musk believes most human intelligence comes through the hands. He says that over millions of years of evolution, no part of the human body has been as crucial as the hands. Even in the early days of human thinking, our ancestors built amazing structures and did complex tasks without needing advanced brains. That's why Elon Musk and Tesla made hands the main tech focus for Optimus. Musk thinks these hands will set Optimus far ahead of competitors, making it the most advanced humanoid robot in the world, capable of solving hundreds or even thousands of tasks. Today's episode is everything you need to know about Optimus hands. Welcome to Auto Intel. The new Optimus 22 degree of freedom hand and forearm is now being made. It's learning to walk and catch balls. It's pretty awesome. I mean, look, that's where we started. It's wild. In a very short time, Optimus has gone from just an idea to the most advanced humanoid robot on Earth. If you want a humanoid robot that can do what humans do, it's a really high goal. Our new arm has 22 degrees of freedom instead of 11. Copying the human hand's movements in a robot is never easy. The best engineers in the 21st century know they're racing against time to match the 2 million years of evolution that made the human hand the most complex biomechanical structure ever. If you had to pick a body part with the most complicated motion, it'd be the hand. The human hand can do tons of movements: grabbing, pulling, pushing, flicking, pressing, chopping. Try listing that many movements for any other body part, and the hand always wins. That's why Aristotle once called the hand the tool of tools. Our hands have 27 degrees of freedom, and we can do any task within our ability with them. With 5 bendy fingers, hundreds of sensory nerves, and a super complex mechanical setup, the human hand is the perfect tool for creating, working, and expressing ideas. So, building a machine that can mimic the human hand's flexibility and smarts has been a big dream in robotics for a long time. It's a tech peak that thousands of engineers worldwide have been trying to reach for decades. But when Elon Musk said the next version of Optimus hand has 22 degrees of freedom, Tesla's Optimus shook the tech world again and sparked lots of talk. Not because of its shape or super smart AI brain, but because of something unexpected. A pair of hands that are very different from human hands. A hand that had 11 degrees of freedom now has 22, making it just 5 degrees short of a human hand. To put it simply, the 11-degree hand already let Optimus fold clothes, water plants, hold eggs without breaking them, install electronic parts, carry battery trays, and even pour drinks. That's just the start, because clearly, both Optimus' brain and hands are still pretty basic. But this makes us even more curious about how advanced a 22 degree of freedom hand will be. When we watch Optimus in action, we have to admit we're not drawn to its odd walk. People often joke that Optimus moves like Biden, and that walk really affects its balance or smoothness. But when we see Optimus handle objects with its hands, we all feel it's at least impressive. Late last year, Tesla shared a demo of its new 22 degree of freedom hands, showing Optimus catching a tennis ball with great accuracy. But few know it took a huge effort for Optimus to do that, because 50% of the robot's mechanical complexity is in these new hands. Yeah, the hand might be nearly half of all the engineering in Optimus from an electromechanical view. The hand is probably about half the engineering. We tried putting the actuators in the hand itself, but then you end up with these giant hands that look strange. In humans, each finger has 3 joints and a complex web of connected muscles. Copying all these movements in a robotic hand while keeping it the size of a real human hand is an incredible engineering feat. Tesla says Optimus has 22 degrees of freedom just in the hand, a number no commercial humanoid robot has reached before, most have only 5 or 6. Each finger can move on its own, rotate, bend, twist, and even do gentle touches, just like a real hand. This means Optimus isn't stuck just grabbing or letting go of things like most robots. It can do detailed tasks like typing on a keyboard, washing dishes, and more. One big reason Optimus Hands stands out is because Tesla chose a motion system inspired by the human body, something robotics has long thought too hard and costly to mass-produce. Instead of stuffing motors into the hand, which often makes them bulky and heavy, Tesla moved all the main actuators to the forearm. Then, a system of stretchy cables, like human tendons, pulls, releases, flexes, and extends the fingers. This works just like a human hand, where forearm muscles contract and send force through tendons to move fingers. The result is a robotic hand that's lighter, quicker, more energy-saving, and super precise. Each cable has built-in force feedback sensors, letting Optimus AI feel how hard it's gripping and adjust as needed. This lets the robot hold an egg without cracking it, tighten a screw with the right force, lift a coffee cup without spilling, and even sense how soft or hard different objects are. This kind of skill used to be limited to fancy robotics labs, but now it's in the hand of a product you can buy. To make such a tiny, powerful system, Optimus needs high-performance servo motors and, importantly, permanent magnets made from rare earth elements. Unlike the big motors in cars, a robotic hand needs super small motors that are still strong and very precise. This is a big challenge for Tesla, as only ultra-strong permanent magnets can meet these needs. But over 80% of the world's rare earth magnets come from China, and with trade tensions rising, China's started tightening export rules to protect its tech interests. This has made it tough for Tesla to get these key parts. Optimus was hit by the magnet issue from China because the actuators in the arm use permanent magnets. Tesla as a whole doesn't always need permanent magnets, but when something's size limited, like a robot arm, you want the motors as small as possible. So, we designed permanent magnets for those motors, and they were affected by China requiring export licenses for magnets. Raw materials aren't the only hurdle. To keep near-perfect precision in Optimus hand while doing tasks, the motors, sensors, and cable systems need to be tuned just right. According to Milan Kovac, the lead engineer on the Tesla Optimus project, the team is working on several big upgrades, especially adding a new tactile sensing system. A key feature is that this new layer of tactile sensors will cover a much bigger area than before, giving the robotic hand a better ability to feel textures, pressure, and even the temperature of objects it touches. In a video of Optimus catching a tennis ball, once the robot grabs the ball, it doesn't let go right away. This shows Optimus is making sure it has a solid grip, even checking if it caught the right thing. All this is possible because of tactile sensors that let it truly feel the object, something most of Tesla's rivals haven't pulled off yet. This upgrade isn't just about adding sensors, it needs complex tuning of the control system. The engineering team is building a control system based on artificial tendons, mimicking human hand tendons for smoother, more precise movements. This lets the robotic hand not only open and close but also handle fragile items, type on a keyboard, or tell the difference between hard and soft materials. But these advances bring new problems. Adding such a complex control system to the forearm has made that area heavier, which messes with the robot's balance and its arm's ability to work for long stretches. To fix this, the team is now trying to lighten other parts without losing power or precision. Another big part of the improvement is designing the protective covering for the fingers and palm. This layer needs to be soft and flexible enough to keep the hand nimble and safe when touching humans or objects. But it also has to be carefully designed so it doesn't block the hand's tactile sensors. This is a tough technical puzzle. If the covering is too thick, the sensors can't feel properly. If it's too thin, the hand wears out or gets damaged from constant use. All these upgrades aim for one big goal, a robotic hand that's not only strong and precise but can feel the world like a human hand. This is a huge step toward making Optimus a truly helpful assistant in daily life. Tesla started testing Optimus on the production lines at the Fremont factory in early 2024, where it's been working as a worker. A robot that just walks and talks doesn't bring much value. But with a hand that's both flexible and strong, it can do real tasks, from the factory to your home. Optimus can now pick up tiny parts, tighten screws, apply glue, assemble devices, carry delicate items, and even check products for flaws using its tactile sensors. Once it's in homes, Optimus, with its super nimble hands, could do laundry, fold clothes, cook, wash dishes, mop floors, clean up, open doors, carry groceries, or play with pets. Beyond practical tasks, Optimus hands also open the door to social connection. A robot that can clap, shake hands, gently touch a shoulder, or comfort an elderly person with a soft pat on the hand creates a new level of emotional bonding. This is especially key if Optimus is used in elder care centers, hospitals, or special education settings, where gentle touch can make people feel cared for and understood. With its built-in tactile sensing system, Optimus can figure out the right amount of pressure to use when touching someone, not too hard, not too soft, making it safe and pleasant. Though Elon Musk has often mentioned a $20,000 price, we're skeptical of that number, especially since Optimus faces two big production hurdles: high-performance permanent magnet motors and supply chain issues. Almost everything in Optimus is new, there's no existing supply chain for the motors, gearboxes, electronics, or actuators. Really, almost nothing in Optimus, except the AI computer, which is the same as the one in Tesla cars. It's clear not everything can be reused from Tesla's EVs. Everything in Optimus has to balance size and power. In an EV, adding a few dozen pounds isn't a big deal, but for a humanoid robot like Optimus, weight directly affects how well it moves and performs. That's why building Optimus, especially early on, was never going to be simple. Even with Tesla's top-notch engineers and huge factories, progress will likely be slow, and production costs won't be low enough to hit a $20,000 price anytime soon. Elon Musk himself has said producing 1 million Optimus units a year might not happen until 2029 or 2030. That's why we think it'll take about 5 more years before Optimus can cost $20,000. If Tesla starts selling a small number of units next year, we guess the price will be around $40,000, about the cost of a Model 3. At that price, many middle-class American families might be willing to buy if the robot can reliably work 8 hours a day. Tesla says Optimus has a multi-layered behavioral AI system. It tracks every hand movement, checks the force used, and will shut down automatically if it senses anything dangerous. Tesla also includes over-the-air software updates and role-based control limits to make sure Optimus can't be turned into a weapon. A big question is why Tesla, a carmaker, is investing in humanoid robots. The answer is the shift from virtual AI to AI that can act. No matter how smart AI gets, it's just software if it can't touch the physical world. The hand is the bridge between software and reality. With a hand like Optimus, Tesla is leading the way for an era where AI can really do things for people. While Optimus carries the mission of changing human work and daily life, Elon Musk has been honest about it having bugs at launch. That's totally understandable, since humanoid robotics is a super complex field where every move, response, and decision has to be nearly perfect but learned from scratch. One early weakness is Optimus object recognition, which still needs work. Because of limited visual data, Optimus can mix up similar-shaped objects, causing mistakes during tasks. Another concern is response delay. The robot might react slowly or misread commands, especially in loud places or with signal issues. For mobility, while Optimus has balance control, it could still fall on thick carpets, high steps, or if it bumps into pets or objects. Plus, its voice recognition isn't fully ready, especially if users mumble or use unusual words. Its need for internet connection also risks interruptions. If the network's shaky, data might not sync, making the robot freeze or act wrong. Beyond tech limits, Optimus faces production challenges. Tesla can't just reuse its EV supply chain. Most robot parts have to be designed and built from scratch. Elon Musk has also worried about China's control over the permanent magnet supply, which could seriously slow Tesla's production. All in all, while Optimus is a huge step forward, its road to success is full of challenges to overcome. In a world where people want freedom from boring, repetitive, or risky tasks, the hand of Tesla's Optimus could become the first true symbol of tech freedom. This isn't just about walking robots or smart AI, it's about a pair of hands that can feel, act, and change the world. What do you think about Tesla's Optimus? How do you feel about its hands?